To prepare you for the test on exponential functions, here we have 5 questions, which is in the form of fill in the blanks. I'd like you to copy them, answer the question, pause the video, and then look into my suggestions. Part A is expression 4 pi r squared to the power of 0 for r equals to 3 is equal to what? Part B is decay rate for y equals to 25 within brackets 0.87 to the power of t is what? Part C is point of intersection of f of x equals to 2 to the power of x and 3 to the power of minus x is what? Part D is function f of x equals to 1 minus 0.5 to the power of x is decreasing on the interval of what? E is range on the function f of x equals to 1 minus 0.5 to the power of x is what? Write down your answers and then check with that of mine. Here are my solutions. Part A, expression 4 pi r squared to the power of 0, right? Whenever we have anything to the power of 0, what do we get? We get just the number 1, right? So that is the solution. Decay rate for y equals to 25, 0.87 to the power of t is. Now, there are two things. One is decay factor, the other one is decay rate. Now, 0.87 is the decay factor. The rate is, you need to figure out what is 1 minus 0.87. So you get 13, 0.13, rather 13%. So 13% is actually the decay rate. So that is your answer. 0.87 is a decay factor. Point of intersection for f of x equals to 2 to the power of x and 3 to the power of minus x. Well, think about it. Now, if you graph these functions, what do you expect? Let us say we have 2 to the power of x, so it will be increasing, right? All the way like this. And how about 3 to the power minus x? It will be decreasing, correct? Like this kind of. And where will they intersect? They'll always intersect at x equals to 0, since anything to the power of 0 is 1, right? So the point of intersection will be 0 and 1. So that is the point of intersection for these exponential functions. Part D and E, we have same function, which is 1 minus 0.5 to the power of x, right? Now in part D, we say function f of x equals to 1 minus 0.5 to the power of x is decreasing on the interval of what? And the range for this function, right? So it's better for us to kind of sketch the function, right? So we can just sketch the function and then figure out. So let's make a rough sketch of this function. Now, domain has no restriction, of course, and the function could be written as, let me write out here a function as minus 0.5x plus 1. That kind of helps, right? Since we are so used to looking into this equation in that form. So plus 1 means translation by 1 unit up, right? So this is 1 unit up. So that is your horizontal asymptote, right? Now, also look into it in a way that what is 0.5? 0.5 is basically half, right? This is half to the power of x plus 1. So half is less than 1. So as the value of x increases, so you'll find that the function will be decreasing, correct? It will be decreasing. Now that is one part. And second is minus. Minus means what? Reflection on x-axis, correct? So if you have a function, let us say decreasing function like this, so initially you'll have a decreasing function which will be, let me draw the original function, which is half to the power of x. So half to the power of x should be kind of like this. So this function will be half to the power of x. Let me write down, right? So this is half to the power of x. So it is decreasing all the way. Once we reflect it, then what happens? Then this point comes here and we have a function which is reflection on x-axis. So it is kind of like this, right? So that is the reflection. right? So this is the reflection part, and now you move 1 unit up. If you move it 1 unit up, what do you expect? You expect it to move the whole function 1 unit up, and you will get horizontal asymptote of y equals to 1. Do you see that? So that is y equals to 1. So this represents f of x. So that is our function f of x. Now you can answer both the questions, correct? So that's the whole idea, and that's the reason why we have the same function for d and e, so that you can answer it very easily. Function f of x part d is decreasing on which interval? So you can see it is not decreasing at all. It is always increasing, right? So there is no intervals, none, right? So it's always increasing. How about e? Range of the function. As you can see, the range of the function is that y belongs to real numbers and y is less than 1. It approaches 1, but it is never 1, right? So that is the range of this particular function. I hope this fill in the blank set of 5 questions help you to review many parts of the chapter, and you appreciate it. Thank you. All the best.